I'm sorry I don't speak Ukrainian, like Pasha really speak English and Ukrainian. Sorry to...
All our embryology could speak English fluently.
Nice, nice, nice. My topic today is the sperm DNA methylation, because it's a new thing and it's a key of the embryo development. And I want to show you the work that you do this year in the lab to find a correlation between the sperm morphology and the DNA methylation. Today, it's not enough to explore, to investigate the male factor only with the sperm parameters. Sperm parameters like concentration, motility, morphology, it's not enough. We must go deeper because the DNA has a big impact on the embryo development. And if there is some damage on the DNA, you have huge consequence on the disease and malfactor. This is why today it's absolutely mandatory to go deeper and to explore the DNA of the sperm head. You have the chromosome and the chromatin, two things on the DNA. The chromosome is a gene, carrier of the gene and genotype. And the chromatin, there is carrier of the epigenetic carrier, and it's for the phenotype. Normally, for the chromosome abnormalities, we have two kinds of abnormality. One with the number abnormality, like the Klinefelter syndrome with XXY, or the XXX or the Y. This is abnormalities on numbers on the chromosome. And here you have abnormalities on the structure of the chromosome. And we have sometimes an Robertsonian translocation with an equilibration. It's balanced or unbalanced with the chromosome 13 to 14, or sometimes it will come on the same chromosome. This is for the chromosome. Now we can have also this part of abnormality on the chromosome, the microdeletion on the Y. And you know that we have a short arm and a long arm, and in this area named AZF, you have three different points, A, B, C. If there is a microdeletion on the A, it's absolutely rare, it's a severe, and we don't have any spermatozoa, no discussion. If we have a microdeletion on the zone B, it's the same, no discussion, we don't have spermatozoa. And only if we have a microdeletion on the zone C, it's the most common, we have or nasospermia or very severe OTI. And in this case, there is a risk to transmit the same abnormality to the offspring, to the boy. This is for chromosomal abnormality. Now, we have on the DNA, the double helix of DNA, we have the histone. And you can see, this is a double helix, and this is the histone, which is wrapped. The double helix is coiled and wrapped along the histone. And this is the tail of the histone. And this tail, there is sometimes is coming some radical like CH3, methyl radical. And if it's coming in good time, it's okay. If it's not coming or coming later, it makes abnormality and disease. This is very important. Now you can see that this double helix is wrapped around histone, and histone and the double helix is wrapped together to make one chromosome. Now this is a histone molecule in blue, and in green you have the DNA, which is around, and this is a tail of the histone where the methylation could be occur, could be happen. We know that this tail methylation is very important because it's a genomic imprinting. It means that if there is methylation or acetylation on this tail, it's make or the repression or the activation of the gene. The gene can have an expression or be silent. No, it cannot work, it's closed, depending on the presence or no of the CH3 radical. Now this is what's happened during the spermatogenesis. There is packaging all this DNA, and all the histone is replaced by protamine. It's a lot of meiosis, mitosis, and different enzymatic system in the cytoplasm. And during all this time, it's occurred many abnormalities. And you can get abnormality on the chromosome, abnormality on the DNA, and if you don't have the good ratio between histone and protamine, also abnormality on the sperm. And the problem when you are working in the lab and you are looking for to choose one sperm and to inject, there is a consequence on the children, on the offspring that you get. You see that all this histone is wrapped and they make nucleotides and it's compacted. Why it's compacted? Because it's tightly compacted to protect the paternal genome during when he's going in between the tract of the male tract and after on the female tract. And if it's not really compacted for protect it, it's open chromatin, it could be have some alteration with the oxidative reaction, infection, or pollution, or tobacco, or different things. This is a condensed chromatin with an histone and protein, and if it's expanded like that, it's open. This is absolutely abnormal, and if you inject a sperm with an open chromatin like that, it means that it's a young sperm, because you have more histone, expanded chromatin, and you must discard this kind of sperm. Now, the last, on the methylation. This is the DNA. This is a DNA with unmethylated DNA, and there is an enzyme, its name is DNA methylation transferase, come here and put all the radical on the DNA chain. This is very important stage during the maturation of the sperm. Look here, this is a cytosine, and here, this is radical CH3 is coming on number 5, because it's like that, and it's 4, 5. It's coming here, and this is methyl on the cytosine base, and it's closed. This radical is like a key. When it's coming, everything is stopped. No transcription, no gene expression, nothing. And the problem is, it must come to arrest the programmation of the protein. But if it's coming too early, we have a deficit of the protein. If it's coming too late, we have an excess of protein, and make an arrest of the embryo development, which is very early embryo development, or it can go later, and you have a disease when the baby is born. Now, what I explained you, this is a cytosine in blue, and this is switch on gene because it's open. There is no methyl radical. This is open, and the histone is acylated. This is a transcription, it's okay. It's open and it's working. And when the CH3, this is CH3 is coming, the gene is switched off. It's closed, no expression. More in this slide, too easy to understand that there is a promoter and the gene. This is an expression because it's unmethylated, and in this, with the CH3, is methylated and it's closed and it's silent. There is no expression of the gene. Now, what's happened when you make a fertilization in the lab? This is a pattern chromosome coming from the sperm, and this is a maternal chromosome coming from the oocytes for to get the baby. For example, for this case, you have two genes, gen 1 and gen 2. For the paternal chromosome, for the gen 1, it's open, it's working, there is an expression of the gene because there is no radical methyl. But this one is close with the methyl. Inverse. Here, the gen 1 for the maternal is closed, and this one, it's switch off. And the children have an expression with the gen 1 from the father and the gen 2 for the mother. This is a consequence. Now, this is a theory. When you are in the labs, it's absolutely different. This is to understand what's happened. And we know that we have many DNA testing. We can have an exploration with the DNA fragmentation, sperm chromatin decondensation, and you have an evaluation of the methylation. But you never have a real test, and you cannot use the sperm because the sperm is staining, it's fixed, it's dead, and you cannot use it. You have just a numbers with a prediction value, with an evaluation of the spermatozoa, the quality of the spermatozoa. But where you are looking for one and inject inside in a real time, you cannot know if it's abnormal or no. This is why we thought that we can find a correlation in the lab. This is a sperm. You can see how it's look, how it's moved, but for us it's more important to understand what's happening inside and to understand what's the kind of the DNA, what is the quality of the DNA is inside the head of the sperm. And after that, you can have a very real evaluation of the sperm quality. You can see on this slide the same sperm in high magnification. This is 6,000 and low magnification. This is an XC routine, is 400 times. And you can see that the approach, the morphology is absolutely different. We are not talking about macrocephalic, microcephalic, round spells, tapering, or angulation. This is easy to find it, to read it, to get it on low magnification. More important is the fine morphology of the head, if there is an extrusion, an evagination, if there is a vacuole. And here, on the basis, it's also a very important point, there is a centriole. And the centriole, there is all the system for the migration of the chromosome after the syngamy, after the fertilization. And this is why we published in a previous work a few years ago a classification, a scale classification choosing the sperm at high magnification. And you can see here, this is a top sperm with 6 points. 6 points, it means that you have no abnormality on the head anyway. And it's scoring 6. And this is the worst. The worst because you have abnormality on the centriole here, on the basis, near the neck. You have a vacuole, and you see this, it's an extrusion of the morphology of the head. This characteristic, you cannot detect it at low magnification. In XC routine, you cannot see it. This is a problem, the high magnification. And sometimes you can see and read some paper that said that MC or high magnification don't bring something else. It's true. It's true. It's depending which sperm you are looking, which kind of sperm you are working, and which condition of selection of the sperm you are doing for the inject. If you have abnormal sperm, like in XC routine with, 5 millions and with the motility of 30 or 35 or 20, it's the same sperm. You can do it in XC and you get in high magnification in MC, it's the same. There is any difference. But if you are looking to choose one sperm with this abnormality on the head that you cannot detect them on low magnification, this is important. And the consequence, this is what you do. We make a global sperm methylation of this kind of sperm. And we thought that if you have on a scale score 6 for the best one and for the worst 0, it's easy, 0, 6. And we think if we can find an abnormality DNA inside this different morphology type of sperm at high magnification. And we make a system with a global methylation cytosine. It means that you are looking how many radical methyl we have on the different kind of sperm. And we make for that with antibody, special antibody against 5-methyl cytosine, and with the system sandwich, you make a revelation of this antibody to see if there is a fluorescent light, it's coming, if it's positive, and it's not, we have a negative. And you can see here we have 3 spermatozoa scoring 6. This is best one, the top. And there is negative methylation because there is any fluorescent, and in microscope you see it's blue. Inverse. This is a partial methylation because you have here a little light in fluorescent, but it's more evident here. You have 3 spermatozoa scoring 0. This is the best, the worst one that you cannot detect in low magnification, and you see this is methylation. It means there is all the sperm have a methylation, but this sperm have a high ratio, a high level, high profile of methylation, and there is more gene that block with its young spermatozoa, and when it's blocked too early, there is no programmation of the protein. Now, this is the result. We analyze 10 patients. For each patient, we take the sperm 6 and the sperm 0, and we make a global methylation. It's not published yet, but I hope so it will be in a few months, because it's writing, it's not easy to take time to do it. And you see, if we analyze around 50 sperm on the slide, score 6. We have, this is a number of sperm with hypermethylation. It's 8 for 90, for 49, 9 for 50. It's around, on total, 15 of the sperm that have an hypermethylation. Inverse, for the same sperm, for the same ejaculate, for the same sample, on the same slide, we make 0 and 6. You see that here we have 40, 32, and it's make an average around 30. And it's very, very huge difference, important difference. In the results, there is a distribution completely different of the score 0 and the 6. It means that the distribution on the score 0 is higher. The ratio is very important with in the hypermethylation sperm. And this, it's very low, and it's more close than the normal morphology. This is the last results. You see that we get 66 out 448, make 15%, and when you make a calculation of the P, it's very, very significant. And with a node ratio of 2.4. It means that when you have selected the sperm score 0, you have 2.4 more risk that you have an hypermethylated sperm with more CH3 radical inside the sperm head. And when you make this statistic calculation with Wilcoxon, it's making a no parametric test. It's also very, very significant. Now, in conclusion, again, I don't say that you need to have for every patient to have a high magnification, but with the high magnification, you can avoid the worst, which is scoring 0. And this is getting more blastocysts because it's not stop the early embryo development, and we can have a better sperm with better compaction of the chromatin. It means that you can avoid the expanded chromatin sperm, and you decrease by 2.4 the hypermethylation risk. And in another study that we do before, for the follow-up of the children born after these two techniques, we found that they decrease the risk of birth defect of the major malformation of the children born by 2.5. And that is the conclusion, and thank you very much for your attention.
No question. I would like to ask you one question.
Yes.
No.
Most we should measure as many parameters of the sperm as we can, but overall, do you perform such diagnostic tests? Not the actual sperm selection during the EC procedure, but the diagnostic tests with, for example, DNA fertilization or sperm methylation, say, before the program starts?
Yes, sure. For each patient, if it's male factor, before to include in ICSI, in IMSI, or in IVF, we have an evaluation of the sperm. This is why I told you that the sperm parameters, it's not enough. You have unexplained, for example, infertility, and sometimes it's the quality of the sperm. You have normal parameters, normal concentration, normal motility, and normal morphology, and after you have no fertilization. And when you are looking, you can find there is DNA fragmentation, for example, or you have a sperm decondensation with the chromatin. We do all these tests. And also we do one test more, and we make an evaluation on the part that you are using for ICSI after a double centrifugate gradient. And in this part, we make an evaluation on the quantity of the score 0 sperm. If the score 0 sperm is low, we go in ICSI. You don't need to have any evaluation. And also if the woman is young and you have good oocytes, for example in egg donation, you don't need to have very, very, very good sperm because the young oocytes can repair some abnormalities. Not the worst, but can repair some of them. But if you have an aged woman, this means 33 it's become, of the quality of the sperm, of cytoplasmic, there is not the same level of enzymatic, of energy, and the quality of the oocytes decrease, you need to go in IMSI. And also, if you have a high level of score 0 and evaluation. If it's around 40-45% of score 0, the risk when you are working to take is 1 for 1, 50-50. This is we go in IMSI. But if it's 10% of score 0, you can stay in IMSI.
And I would like to ask you another question. For example, if you have the case that absent fertilization, you would like to make the whole investigation concerning the sperm and predict it is possible to achieve the fertilization and development of embryo in this case or not. Have you some indicator that shows the patient that we have not achieved the fertilization or not?
No, just the test that I told you. And if you have an evaluation of the sperm chromatin, of the DNA fragmentation, on the level of the methylation, and of the level of no.
Could you do you
no, you can, because sometimes you have another problem. You know that the sperm is tightly condensed, and after the fertilization, then some enzyme coming from the cytoplasm of the oocytes for to open that, and sometimes there is and no fertilization.
Yes. But
no
in this situation, because когда мы имеем пациентов, у которых мы не получаем удовлетворение, это нормально стрельно, это редко бывает. Что им говорит консультация эмбриолога? Кто им скажет, это уже не важно, а что им говорит? I said that sometimes we have the patient with absent fertilization.
But it's young is normal
form. It is very rare, but it could happen.
And also, you must see also the dilation.
Dilation, yes. I agree. And another situation, we have the patient with the fertilization and with the absence of plasmulation. Yes, could we predict it, could we try at least to find something in this sperm in this situation?
No, and we have no predictive value.
No,
it's just no. You can think some, but the decision of that, you are doing many blastocysts in labs. If you have 8 cells on day 3 and the regular cells, you can go.
То есть, о чем я говорю, что другая ситуация. У пациента, это характерная клиника, которая много бластоцистных переносом, участок становится все больше и больше. То есть вы получаете, допустим, так сказать, 8-клеточный эмбриолог, и не получаете бластоляцию. Консультация эмбриолога, что сказать людям? Знаете? Считает он, что сперма здесь ни при чем. Тогда проблема, так сказать, именно в рожденном дефекте яйцеклеток.
You know that the expression of the sperm is after day 3. From 0 to day 3.
You understand that
it's
it's more philosophical question, because according to theoretical knowledge, before the day 3, it's a development only oocyte.
Yes.
And after this,
there is an expression of
activation of the embryo genome and development of plasma.
Exactly.
Yes,
Exactly.
True.
This is why if you have no checkpoint on day 3, it's not okay. There is any interest to go in there.
That this functional song finished in the fertilization. Yes.
Yes.
Yes. Ну и последний вопрос. What is your attitude for the use of ionophore for the
yes, I know. But no, we are not using that. I know that there is some region now in some company sell it, but we don't do it now.
Но уже сейчас идет такая ситуация использования ионофора. Вообще новое, это хорошо забытое старое. Использование ионофора было еще в 90-е годы, когда я еще припал в природу, да? Но потом вроде как сказали, что оно не работает. Сейчас пошла какая-то волна, что оно чего-то дает, но непонятно в каких ситуациях и кому. Дальше, ну, к сожалению, у нас, так сказать, чего-то убежал. Павел, я вас ищу, звоню, и так далее. То есть у нас еще есть время, пожалуйста, давайте продолжим.
Еще вопрос есть.
Вопрос.
Мистер Сазалов. Неизвестный был.
Да, я все верю.
I want to ask a question about the deeply unmethylated sperms. Have you found them in your experiment? In which group have you maybe found unmethylated? So when it's over methylation, it may be elevated or decreased. Have you found decreased methylation with your sperm?
For decrease, no.
Only high.
Yes, only high.
So in process of the production of the sperms, at some moment,
yes, you're right, but we cannot see that because we are working with a global methylation sperm. For to see if there is an hypomethylation, low level, we must work on special sequence of DNA. In a global sperm, we know that there is methylation inside, but you must go very deeper, and it's way just detects a high. And like also inverse, if it's low, it's also consequence.
Could we modify genetic sperm branches by some specific therapy?
For specific?
Therapy. Specific.
I don't think so. There is some specific therapy.
Вопрос еще есть? Если нет, I would like to thank you for the presentation. It was very discardable question.
Без заключения результатов в редких случаях, когда действительно нет неоднородного творения, или очень низкий уровень управления, мы используем мотивацию с помощью ионофора. Конечно, это не панацея. Некоторые способы заранее сказать, кому может помочь, кому-то может помочь, кому не поможет никак, я не знаю, пока не попробовал. Терять себя на нечего, все равно. Может было время выйти, это говорит о том, что при нормальном количестве ацетов, правильно хотели больше 4. Если не организм не платится, то на следующий раз врач просит применить этот метод.
Ну, он, по крайней мере, может, не поможет, но не поможет.
Да,
а насколько он может помочь?
Ну, иногда организм просто полностью переворачивает. Видимо, 80-90% оплодотворения цифров не было ни одного. А дальше все помогает процесс говорить. То есть некоторые заключения, даже исследования некоторых методов было закончено, выжили какие-то статьи на эту тему. Просто мы давно этим занимаемся. Дети нормальные уже. Нормально. То есть никаких серьезных дефектов. Но опять же, причину мы до сих пор не знаем. Что-то мешает активации.
Ну, на языке
это не связано со стервой, это может быть связано с ацетом. Мы этого не знаем. Где-то на этом перекрестке. И в каком месте бесконечное количество.
На языке медицинского протокола, скажем так, кому это показано?
Только тем, у кого полное отсутствие оплодотворения в X. Опять же, смотря откуда это. У нас бывает, мы работаем с размороженными материалом тестикулярных биопсий, в тяжелых случаях. И там очень низкое. Вот чувствительно хочется, чтобы было больше. Мы иногда применяем, иногда помогаем. Иногда не помогаем. Но опять же, когда одна-две циферки оплодотворился, иногда врачи просят. Но сказать, что это правда нам не трудно. Опять же, я достал очень аккуратно, что работаю, только действительно в тех случаях, в которых нужно. Четких рекомендаций по этому поводу нет, потому что в большинстве случаев это экспериментальные методы, нужно разрешение определенное этим пользоваться. То есть мы прикрываемся пока с разрешением медицинской комиссии нашей организации. Вот. Мы это исправим. Наша цель, чтобы в конце концов забеременеть, чтобы было не работать дальше.
Ну, я, например, пытался вот эти показания, значит, считается, что показания не полное отсутствие оплодотворения, или 30, ниже 30%. Ну, как считать ниже 30%? Оплодотворение. Если получили 15 яйцеклеток, а из них оплодотворили 6, потому что это не 2, то считают, а тех, что подлежали оплодотворению. А если получили 15, то есть, если это оплодотворение, там, ниже 30%, порог.
Опять же, скорее всего, в тех случаях, когда низкий процент оплодотворения, по логике вещей, по-моему, это даже как сильно менять картину, потому что речь идет, если какие-то сперматозоиды оплодотворили, то есть, опять же, это связано с яйцеклеткой и сперматозоидом. Если вообще есть какая-то проблема с синхрозом, то, по-моему, вообще не было никаких оплодотворений.
А вот вопрос, есть какие-то данные по соотношению? Вот, у нас клинические, да, то есть какие пациенты, которые в предыдущем цикле молодая, и тогда было в тот момент 28 лет, не получили оплодотворение, что было 8 клеток. Показатели нормальные, 20 нормальные, ну, как бы, да, исичный случай. Второй цикл XI проявил без анафора, ну, так сказать, да, надежда на то, что вот, да, просто методом повторения получили какой-то результат, опять ничего не получили, но взяли еще 2-3 донорские клетки из донорского цикла, оплодотворили этой спермы, не получили оплодотворение. Мне интересно, как часто, есть ли какое-то соотношение, есть данные по соотношению, когда вклад яйцеклетки, когда вклад сперматозоида?
Я выкручу из этого вопроса и пополам.
Понятно. Просто...
Отсутствие оплодотворения?
Да, там полное отсутствие оплодотворения. Сколько соотношений?
Нам трудно знать точно. Я думаю, что интуитивно, я думаю, что все-таки это больше всего связано... Нет, да, кто-то живет. Но сперма совершенно нормально выглядит. Во многих случаях. Нет, даже на мозге, даже...
Алексей, давайте завлечем нашу дискуссию. We have a discussion about the ratio between the male and female factor in the absence of fertilization. Вот же дело. Ну, пожалуйста, скажите, в какой ситуации?
We had some time ago we had the clinical case, full absence of fertilization, about 8 sites, subfertile sperm, that is quite acceptable for ICSI. And then we repeat again and had one more ICSI cycle, and again we had more realized vegetation. Before this, but
okay, quite, but you maintain high unification.
No, it was.
I think so. It's cases of that.
Sorry?
It's a case that you must switch with identification because there is some abnormality that you cannot detect on the identification. It's a sperm on XC, but if you are looking for a very precise morphology, you can find better sperms. In cases that we have, when you have a failure, you switch directly to identification.
But for example,
and we have
after the switch of X,
yes,
what is the percentage which
70%.
Ну, такое.
How do you see?
And you can also make an evaluation of the DNA fragmentation if there is problem solution. If the woman is strong,
они записано много. You can export more sperm with the methylation of the light, and also if there is pollution, some toxic tobacco. This is in effect. What do you think? What is the ratio between oocyte factor and sperm factor in absence of fertilization?
It's 50-50.
Да. Ну все, значит, давайте таким образом. У нас, как проект запланирован на 10.